Okay. Hello and welcome to the 10th Badger Crop Connect webinar of the 2023 season. I'm Sam Bibby, the Regional Crops Educator for Sauk, Vernon, and Juneau counties, and I'll be your host today. The Badger Crop Connect series aims to provide timely crop updates for producers and agricultural professionals in Wisconsin throughout the growing season and is jointly sponsored by the UW-Madison Division of Extension Crops and Soils Program and the UW-Madison Nutrient and Pest Management Program. A little bit of a local update. It's probably not very local. For us, beans are coming off pretty quick. A lot of folks are over halfway done. Seem to go from not ready to everything's ready on our farm, at least, in a matter of a few days. Just as fast as beans are coming off, rye is going on as a cover crop, as well as a few other cover crops. And then as extension agents, at least myself included, we're putting in some plots. One kind of exciting one we've got going on this year is a comparison between camelina and rye as fall cover crops. Camelina is sort of a new cover crop on the scene, I guess. It's a broadleaf, it's a brassica, so pretty similar to canola. It's really winter hardy, and we're hoping that maybe it could be a broadleaf rye essentially, and maybe that would fit better before corn than rye. So it's something we're interested in. We're putting in a few different plots. And in addition to just comparing the two cover crops, we're also installing these resin pucks you can see on the bottom left corner there. At least that's what we call them. They're sort of like a poor man's lysimeter. They contain about a known amount of resin inside those PVC containers that is the same resin used to filter nitrates out of your water, like in your home if you have that problem. And so what we can do is bury them in the soil profile, and then come back in next spring, we'll dig them up again. We can pull that resin out and get it analyzed in the lab to see how many nitrates pass through that container and get an idea for what the nitrate leaching might be in the different cover crop treatments. So that's what's going on with at least a couple of your local extension agents. So back to the housekeeping. As a recipient of federal funding, UW Extension must collect information about its outreach efforts. As a part of your registration for this event, we requested that you provide your demographic information. All information collected is anonymous and cannot be tracked back to you. Thank you for your assistance, and we will start the webinar pretty soon. While many of you are familiar with our virtual presentations and the Zoom platform, I'm going to go through a couple housekeeping items. Please keep your microphones muted and videos off during the webinar. The mute and video controls are at the bottom left-hand side of your screen. Also, please feel free to type your questions for our presenters into the chat box at any time. The chat box is in the bottom center of your screen. We'll answer as many questions as we can as time allows. If you have any questions or difficulties with Zoom technology, you can type your questions into the chat or alternatively email Scott Royce. Their email will be posted in the chat. If you're having difficulties with your audio, the call-in information will also be provided in the chat. With that, we will now hear from Krista Hamilton, and I believe a couple slides from Josh Kamps as well. So take it away, Krista.
Okay, thank you, Sam. I'm just going to pull up my slides here. Right. Let's go in here. Yeah.
That looks good on our end,
Okay.
Krista.
All right. I think I'm ready to get started. Can you all see my slides okay?
Yep, it looks good.
Good. All right. Well, thank you. I just wanted to say thanks for inviting me to talk about DATCAP's crop pest survey results from the 2023 season. My plan today is to focus in on our corn rootworm beetle survey findings, since those results can influence seed selection for 2024. But I also have some interesting results from our western bean cutworm and soybean surveys. Um, so I'll be, I guess, highlighting a few of those results as well. Let's back up here. Um, so for those of you who may not be familiar with me or the work that we do, I just wanted to quickly mention that I'm a UW-Madison graduate. I've worked as an entomologist with the DATCAP Pest Survey Program for the last 25 years. And I coordinate the agricultural insect survey and detection efforts. And as these efforts have always involved partnership with UW Extension. So I know that I've worked with several of you on projects through the years. I'm hoping that today's presentation will either pique your interest or renew your interest in perhaps participating in some of these surveys or even collaborating on new projects. Now, before getting to the results, I think it's useful just to provide a little bit of context for why we do these surveys. The pest survey program has been around a long time, 108 years in fact, and there are three main objectives that sort of shape the scope of our work. The first objective is pest detection. To detect new and emerging plant pests, and we know that invasive foreign species show up in Wisconsin all the time. So part of our role is finding these new things as they arrive. The second is to collect data on regulated pests of importance to domestic and export trade, which in turn helps us to support export certification decision making by our bureau. And then the third objective is to alert farmers and crop advisors and other ag professionals to pest outbreaks and problems in the early stages when these problems can be, more effectively controlled or managed. We collect data in a few different ways. I think the most common way that you're probably familiar with is field scouting. So we actually go into fields and count insects or look for plant disease symptoms. In terms of insects, this might involve taking whole plant counts or a certain number of sweeps. We also collect data through insect trapping, which involves setting either pheromone traps or blacklight traps to monitor flights of specific lepidopteran pests. And then the third way that we collect data is through networks of cooperators around the state who monitor insect traps and then report their weekly counts to us. And several of you have been cooperators at one point or another, and many of you are currently involved in networks. And I think this is really one of the best features of our program, and it's what makes us unique. We have often long-term participation from growers and extension and other industry folks who know that it's really important to bring these tools to their farms to understand pest pressure at their specific locations. And this is something Josh is going to be talking a little bit more about in a few minutes. So I'll just leave it there. I mentioned that field scouting is one of the main ways that we collect data. We have just a small team. There's two of us and a summer intern. So we're always kind of stretched thin. We can never do quite as much as we'd like. But this map shows what the number of crop fields that we were able to survey in 2023. So we conduct surveys in corn, soybeans, alfalfa, small grains, also in fruit and vegetable crops. And I should mention too that our program has two forest entomologists who conduct forest pest projects. We also have two plant pathologists who oversee plant disease survey work. My role is specifically coordinating the ag crop surveys. This past summer, we surveyed about 700 corn, soybean, and wheat fields. That was a little bit on the low side for us, but we had other work to do. It was a busy season, so we had to kind of shift priorities this year. But keep in mind as you look at this map, so each, although we're looking at 700 fields, at each one of these fields, we might look for up to 25 different organisms. In soybeans, for example, we record counts of bean leaf beetles, soybean aphids, green clover worms, Japanese beetles, rootworms, stink bugs, grasshoppers, a couple of other things. So it actually represents about 14,000 to 17,000 positive pest observations that we collect annually just from our field crop surveys. Cooperator networks are an approach that we've used for at least 30 years to help accomplish our pest surveys. So the way that this works is that we enlist volunteers throughout the state to collect and report data. And as you can see from the dots on the map, we can gather data from a much larger area than our small team could ever really access weekly. So cooperators are really important to us. They come from a variety of agricultural backgrounds, including UW Extension staff, apple growers, agronomists, farmers, crop consultants, even gardeners. So in 2023, we coordinated 8 different trapping networks, as you can see on the map. So about 50 of these, somewhere buried in here, are 50 black cutworm traps. We set 42 western bean cutworm traps, 12 earworm traps. And then Josh Kamps, Tim Meyer, Mandy Schick, and Julie Hill, between the 4 of them, independently ran our true armyworm traps. So there were 14, all of our armyworm traps, 14 true armyworm and 11 fall armyworm traps. And then we also set 8 blacklight traps. So we also set another 342 traps as part of our fruit and vegetable pest surveys. In all, this totaled 479 traps across the state this season. And again, this was largely due to help from volunteer cooperators. And we're really grateful for that extra effort that they put in at the busiest time of the year. So that just gives you an overview of what we were up to this past season. And now I want to kind of get into the results of our corn rootworm survey and some of the other surveys that we conducted. So our corn rootworm survey has been conducted nearly every August since 1971. There was just a brief gap from, I think, 2000 to 2004, where we just didn't have the resources. But we've now conducted it consistently since 2004. It takes place during the peak period of beetle emergence, and that's generally from about the first week of August to the 3rd week of August, and sometimes it goes a little bit longer. The protocol that we follow for the survey is to count beetles on 10 whole plants per field. These are widely spaced by about 25 paces. And then we calculate an average number of beetles per plant for that field. We call that the BPP. So the economic threshold, or what's considered high for continuous corn, is a BPP of 0.75. That's about 7 to 8 beetles on 10 plants. So the beetle counts that we're collecting during this survey indicate a couple of different things. They're indicating current year beetle pressure. They're suggesting egg-laying potential. So if you have a lot of beetles in a field, there's potentially a lot of eggs going into the soil. And then ultimately, they can help us to forecast root damage potential in continuous corn the next season. So in 2023, our survey found a drop in beetle populations compared to the year before. The state average for the season was 0.05 beetles per plant. That was a pretty sharp decrease from 0.9 beetles per plant in 2022. If you take a look at this list, you can see about 69% of our survey sites had either no beetles or low beetle counts. 13%, so all of these yellow circles on the map, had moderate beetle counts. And then 18% of our sites, or the dark orange circles, had high beetle pressure. So during the survey, we count northern corn rootworm beetles, western and the southern species. And if you take a look at the total counts here, you can see again this season the northern species outnumbered the western species by about 2 to 1. That's been the case for about 10 years now. Prior to 2014, the counts were generally more even between the two species, and there were lots of years when when the western corn rootworm beetle outnumbered the northern. So the trend that we've seen for the last 10 years is a little bit different than what we had seen earlier. The northern species has been the dominant species for about a decade. So it's helpful to look at the average beetle counts by crop district just to see, where some of the decreases occurred and where were the hot spots. And immediately it should be clear that some of the largest decreases were in the southwest area and in the east central area. So the drop in the southwest was a little bit surprising, given that we had such a high average in 2022. In the east central area, it was a dramatic decrease, not quite as surprising because we don't typically see extremely high beetle pressure in that area. And the average that we found in 2022, that 1.1 beetle per plant, was kind of an anomalous high average. So the hot spots that I mentioned were the south central and southeast areas. That's where we often see the highest pressure, as well as in the southwest. And then, if you take a look at averages across the other 6 districts, they were generally pretty low. When we look at the last 10 years of survey results and compare 2023, I think you can see this year's counts were really kind of in line with what we've seen earlier in the last decade. And then 2021 and 22, these kind of high population years are kind of the exceptions. We just saw really high beetle pressure, and then kind of this dip for 2023. You're probably wondering why, and there's always lots of possible reasons for this decrease. I tend first to think about environmental factors. What were soil conditions like when the larvae were hatching? Were they unfavorable or were they favorable for hatching larvae? When we consider that the peak egg hatch this season for Madison was somewhere likely during the week of June 18th to 24th, that was a point when soils were really drying out. Still not at the point where I think we would say it was drought conditions that led to high larval mortality. I think at that point, things were still okay for eggs that were hatching. Instead, I think probably a more likely scenario is that we saw higher chemical inputs in anticipation of higher rootworm pressure going into the season. And that might account for part of the drop in the southwest and east central areas. So with last year's high beetle pressure, problems were anticipated. I think producers were really prepared to kind of thwart rootworm pressure this season with soil insecticides and BT hybrids. And then also insecticides that are applied with tar spot fungicides are something that have become a lot more common. And these are applied in the early reproductive corn stages. And I think that too may be something that's contributing to the reduction in beetle populations. For next season, our survey results suggest that beetle pressure is likely to be high across southern Wisconsin, as is usually the case. But it looks like the main problem areas will be concentrated in southern and part of the western region, and elsewhere, at least based on our numbers, we're not expecting significant issues. One parting thought that I wanted to just mention is about extended diapause in the northern corn rootworm species. I mentioned earlier that the northern species has dominated for about a decade now, and in some fields, northern corn rootworm levels can be really extremely high. We don't really have a good handle on if or where extended diapause problems are occurring in Wisconsin. We know Minnesota is starting to see more issues with this rotation-resistant northern variant, but I guess what I'm trying to say is it's potentially a good topic for future collaborative projects, just to get a better idea of if this is an issue for Wisconsin. All right, so I'll move on to talk about our Western bean cutworm survey. It was a big year for this insect. In fact, the 2023 survey collected just over 9,000 moths. That was our highest total catch on record. The average for this year was 222 moths per trap average. That was an increase from an average of 133 per trap last year, when the survey found about 4,800 moths in 36 traps. So this year's average is the highest that we've seen since we started trapping for this insect back in 2005. You can see from the map that the highest counts are concentrated in Columbia, Marquette, Green Lake, and sort of that northwestern part of Dodge County. This is our traditional hotspot area. We always see the highest moth counts and the highest larval pressure in that area. About a third of our sites had cumulative counts above 250 moths per trap. And then the highest count that we recorded for the season was 850 moths near Princeton and Green Lake County. And we know that this large emergence translated into some heavy larval infestations. During our fall corn borer survey, we also record ear caterpillar counts in the fields that we're sampling. And we're not quite done with that survey yet, but so far we have found Western bean cutworm larvae or evidence of larvae in about 20% of our survey sites. So that's higher than we typically see in a given year. And in some cases, we're seeing larvae in 10 to 12 of the ears, the 25 ears that we sample for European corn borers. So it's definitely been a big year for Western bean cutworm. We also sampled about 160 soybean fields this season, looking for soybean gallmage, for soybean aphids, Japanese beetle, and other defoliators. Funding for much of this work came through Emily Bick's lab, and that was through the North Central Soybean Research Program. And we're really grateful for that support. It made a lot of this work possible. As you can see from the map, our survey found extremely low aphid counts. All of the fields that we checked had averages below 25 aphids per plant. None had economic populations above the 250 aphid per plant threshold. In addition, we found no evidence of soybean gallmage in the fields that we sampled. The most problematic soybean pests this year were definitely Japanese beetles, which has been an issue the last several years, and two-spotted spider mites, which I guess capitalized on the drought conditions. And just for your awareness, this is the current soybean gallmage distribution map. As of this season, infestations have been found in 164 counties in 7 states. There were 6 new counties added to the Iowa's distribution map this year, and another 2 counties in Kansas. Currently, the closest known infested county is up here in eastern Minnesota, Rice County. That's just about 70 miles from the Mississippi River. So we anticipate soybean gallmage will reach Wisconsin soon. In fact, it could already be here. We just haven't found it. So this is something that you really want to be aware of and looking for as you're out scouting soybeans. So those are just a few things that I wanted to highlight from our 2023 surveys. We have a lot more information available if you're interested. And I just want to know, I'll let you know how you can access our findings. So we have a relatively new e-newsletter, Field Notes. This is where we publish results from our surveys, also some of the noteworthy observations from our field work. During the growing season, we try to publish it once a week. In the off season, it's usually just kind of an end of season compilation of our surveys, and then we issue updates as needed. And we have a website, so you can just go directly to our website to subscribe. Another place to find our survey data is right on our pest survey web pages, pestsurvey.wisconsin.gov. And then from our landing page, you can see there are buttons where you can access the individual pest monitoring data for things like armyworms or corn earworm or Western bean cutworm. And if there is specific data that you're interested in or maps that you'd like, I can always provide those directly to you. Just send me an email. So I'm always happy to share that information. And then I just wanted to say thanks again for providing the opportunity to talk about some of these survey results and what they mean for 2024. If you're looking at, if some of these maps didn't have dots in the counties that you represent, those are definitely counties where we could use help. They're good candidates for new cooperators. So please keep that in mind. And I just want to say, again, special thanks to everyone here who helped set traps this year and supported the work that we're doing. And thanks to Emily for that funding for the Gallmage survey work. And with that, I think I'll hand it over. I'm just gonna, maybe I'll check the chat quickly here. And then I'll hand it over to Josh. Let's see here. Oh, nothing important in the chat. So I'll turn it over to Josh.
All right, thanks, Krista. Appreciate
Yep.
it. And if you want to stick around in case more questions come up toward the end of the Zoom, that would be great.
Sure, happy to.
Josh, your presentation looks good.
Hey, that's awesome. Thank you very much, Sam. I'm going to leave the video off. So I pretty much look like the picture shows. But yeah, Josh Kamps, Regional Educator, Rock, Jefferson, Walworth Counties. Krista mentioned that we were able to collaborate on some true armyworm survey work this year. So here's just a look at some of those extension regions across the state. I mentioned that I'm Jefferson, Rock, and Walworth, but other extension regions where you do have regional educators, crops educators that you can connect with. If you go to the Crops and Soils webpage and click under people, that's where you can find us. If there's any other questions or if you're interested in participating next year. So why did this trapping effort begin? Well, in the southern part of the state, we definitely had a true armyworm invasion this year. Our soil conditions were dry already. Forages had grown up well, but then the armyworms came and really stripped a lot of the leaves and a lot of the quality off. There was some cornfields that got impacted as well, but in general, it was really some of our pastures and some of those grazing forages that took the biggest hit. So these pictures were taken on June 13th of this year. And then just a little bit of a recap here of all the different locations through this 8-week trapping system that we had. We used true armyworm pheromone traps in all the different areas that we collected. Here's what we used for a trap in case you haven't been around or seen these bucket traps. Pretty easy to use. The pictures on the right side, you can see it has the bucket and then the lid just kind of goes on there and twists and snaps. And then you put that little pheromone plug just right in the top and put the lid back on and you're ready to go. So this was the pest that we were looking for. True armyworm. We were trying to see, did the second generation, did the egg hatch happen well? And because we definitely saw a lot of, definitely saw a lot of caterpillars. So we're just curious if, that second generation was able to come through. But all that we really are needing to include is the GPS coordinates of that trap, a nearest city or town, and then that nearest field crop that is growing. So pretty easy information to share, along with obviously the moth count and learning a little bit about identifying the different moths. We did some survey work for fall armyworm. Did not find any this year really to speak of. This was some results from 2021 where fall armyworm did show itself in September and was really hungry at that point, putting some stress on our alfalfa fields. So here's a look at that pest and how we were using this information to try to identify it. But finally, just a slide to end up here with, are you interested in collaborating in 2024? So Krista put that ask out, and I guess I'm going to put that ask out as well. If you do have interest to partner and work on some of this together, the more data we can collect will be better yet. So that's what I have for now. I'm going to stop sharing and give Emily a chance.
Excellent. I'm going to go ahead and share my screen here. Can everyone see this?
Looks good.
Yep.
Excellent. I'll take the silence as or the response as a go forward. Just a heads up, if you have some difficulty hearing me, it's my gravelly voice. I got a COVID diagnostic test yesterday, come out positive. So I'm hopefully going to be charging through this presentation and everyone can understand the information as well. So today, Josh and the awesome folks organizing the seminar asked me to talk about pest management considerations at the time of seed selection, which I know is coming up for the 2024 cropping season. And I'm Dr. Emily Bick. I run the Precision Pest Ecology for Field and Forage Crops lab here at UW-Madison. I'm an extension specialist sitting in the Department of Entomology. I really need to start with some of these kind of the background information. Why do we care about rotating our seeds or seed selections or using the right traits at the right places, the right times? And the big rationale, or the major rationale, is resistance, which simply means the change in sensitivity of a pest population, be it an insect, a weed, or a disease, to a pesticide, resulting in the efficacy failure of that application. So we are trying very hard to keep our tools as useful for as long as possible. And forgive me for walking through, there we go. I hope this doesn't click too far ahead. Forgive me for walking through some of these concepts in cartoon form, but this is how I tend to think about insects, right? So we have something that looks like northern corn rootworm. Obviously, we tend not to target the adults, but this is the example that I'm going to walk through a little bit here. We tend to target the immatures feeding on the root stage, but this one's a little bit more picturesque for the purpose of the definition here. So we have a whole range of insects in our field. And as soon as we put something out there, be it a trait or an insecticide, we are getting a partial application on some insects. We're getting a full application on some insects. And we're actually getting some insects that are able to kind of duck and cover, that are able to choose, that are able to sense where they are in the field and what type of either trait or chemical that we've put out there. And the result is these three groups of insects, right? So we do hopefully upwards of 90% damage when we put a trait out there, upwards of 90% damage when we insert a chemical insecticide application or pesticide application into the system. But we have three remaining groups afterwards. And this is, keep in mind, after a single application. We have a group that's resistant. These are insects in this case, or pests that have received the full dose, and yet somehow, due to some genetic quirks of theirs, they were able to survive. Which means that next year, or next spray even, or next generation, this group is going to actually be overrepresented in the following life stage, the following population. We have some insects that receive a partial dose, and oftentimes a partial dose is enough to damage or kill or result in mortality for insects, but sometimes it isn't. So these can be partially resistant insects. And then we have a group that actually is able to kind of duck and cover, right? Insects have this great ability to sense through vision, through olfactory, to realize something's not quite right, and they avoid getting that dose. And these we categorize as behaviorally resistant. So we now go through and we apply a second round, and this could be either a second year's worth of traits or a second spray within season or a spray the following season. And out of this, we then get some level of efficacy, but it's significantly lower than that first round of efficacy. And obviously this is just a cartoon and an estimate here, but within this group, we have insects that are behaviorally resistant that can avoid that application or avoid feeding on those particular roots, as the case may be. We have insects that received a partial dose and were able to survive that and can do it. Their progeny can do so in the future as well. And we have insects that are fully resistant. We go through and we do this process over and over again, and we get what ends up being an overrepresentation of these individuals that can avoid the trait or avoid the mortality effect of the chemical, right? Which means that we then need to switch up traits, switch up insecticides. So what happens when we take a different insecticide and we apply it to this same group, this now pre-selected, somewhat resistant, partially resistant, behaviorally resistant group? Well, it turns out there's something called cross-resistance, where some of these individuals, because of the fact that they increase the number of, essentially increase their immune response, were able to metabolize this insecticide. Sometimes, and this happens more often when an insecticide is functionally related to the insecticide that a pest is resistant to. But sometimes we get this concept called cross-resistance, which means that we've already pre-selected for these individuals. Now, the good news is, if we take the pressure off, if we take this selection pressure, this intensive trading, intensive spraying, if we pull that pressure off, this population is going to end up going back to the original state or something close to it. And that's because there's a cost. There's a cost for that behavioral resistance, right? Maybe those insects that are ducking out of the way are not as risky, and they're not getting as well fed, and thus they're not as successful in the next round. There's a cost for resistance. Hey, it takes energy and metabolism to develop this feature. And there's a reason the insect didn't have this insecticide resistance in the first place. So if you leave the population alone for a little bit, or you just take off that pressure, then all of a sudden you get a population that looks a lot like the population you started with, right? So what are some kind of general practices to conserve these tools? Well, we talked a little bit at the beginning about crop rotation, right? If we pull the pressure off with traded seeds, all of a sudden we can get insects that are responding like they used to respond to those traits, or responding like they used to respond to the insecticides. If we rotate out the tools, which means we're only using one tool at a time, right? Or one year we use, let's say, insecticides, and one year we're using traits, and we rotate those through, then we're actually going to have lower resistance in your particular field. And if we decrease the amount of insecticide, so let's say we're using a traded seed, something as BT that's should be somewhat resistant to corn rootworm. If we lower the insecticide usage, if we don't just do that add-on spray, then all of a sudden the likelihood that you have a resistant population next year goes significantly down. So these are kind of just general practices to conserve tools. But one of the issues is oftentimes the target stage of the insect is not something that's particularly visible, right? We can all count the beetles, and I know we had a particularly bad beetle year this past year, but it's a lot harder to actually figure out what's going on below ground, right? So how do we know if your field should be a candidate for some of these traits? How do we know what your actual corn rootworm issue is, right? When we can only observe easily anyway the adult stage and not the larval stage as they're feeding on the roots. Well, it's something that my lab's been working on, the precision ag sphere or digital entomology sphere, is a device called the insect eavesdropper. I brought it to the Arlington Field Day, if any of you guys were there. It's basically a really, really cheap microphone. And it's a guitar mic that we clipped onto plants, and we tested if we could actually eavesdrop on insects directly feeding on the plant. So we tested with really large insects to start, tobacco hornworm, right? That thing's over an inch. Colorado potato beetle. Oh my goodness, those are large insects with very visible, observable chomps, right? These are chewing insects. And then once we saw that we could identify or detect those insects, we tested on really small-bodied insects. European corn borer feeding down the stalk of a corn plant, and northern corn rootworm feeding on the root zone of the plant. And for each of these in an extremely controlled environment, in basically a soundproof closet in my lab, we basically put the insect on one plant and put a plant in the room with a microphone on it, without an insect, where we knew what the right answer was to start. And we saw in all of these cases, in the leps, which are the moths, butterflies, the beetles, the coleoptera, the large-bodied, the small-bodied, we were able to detect insects. And these graphs, in gray, there's the plant where there wasn't an insect, and black was the plant where there was an insect. So that's great. We can do some detection. We also ran some machine learning models, and it turns out, at least on this lab data, we can start to figure out what those species are. And I have some field data that looks extremely promising for us to actually figure out how many insects are there out there. But a really critical question, especially when it comes to corn rootworm or European corn borer, is how long does a microphone need to be clipped on to find an insect? And it looks like from our lab data, and actually it was shown in our field data as well, if we clip a microphone on for 40 seconds, we are 95% likely to catch or hear or eavesdrop on a corn rootworm if it's there, and 90% likely to hear a European corn borer if it is there. Just pretty remarkable. But we use the number of chomps or number of chews as a way to kind of back estimate density to hopefully in the future make some economic decisions. And that's where the number of peaks come in. Right? So even in that 40-second time period, we're still getting some variance in the number of peaks that we're hearing. So we can then still, in that time frame, back estimate density of insects, which is the really critical missing link to make some decisions. We also tested this in the field, where about 70% of our plants, this was a breeding trial that Natalia De Leon and Sean Kepler's groups put on, and we kind of added on a sensor. It was for corn rootworm resistance. And about 70% of the plants we clipped the microphones on did not have any peaks. And some of the 30% did, which is to be expected. But we also know that corn rootworm are highly aggregated individuals, right? They cluster together, which means that if we were to look at, let's say, site 1, mic 1, site 1, mic 2, or mic 4 would also have corn rootworms, which it did. And if we looked at, since we know something about when these insects are feeding, if we looked at that site 1, mic 1 the next day, that following morning, we would also expect corn rootworm. We also checked these plants for above ground feeding, and these had been seed treated with an above ground insecticide. So we're pretty sure we're catching what we think we're catching. So that's all well and good and exciting. We are in the process of developing this sensor into what we hope to be a very, very, very cheap tool for farmers, for crop consultants down the line. In fact, we received a Walworth accelerator grant to try to turn this tool into, or turn this research concept into an actual tool, and maybe even a company with that produces these sensors. And we're also in an NSF I-Core, a National Science Foundation I-Core kind of customer interview school of training. So if you have thoughts about this, about the sensor, about what its capability is, where it would be really useful, I would posit that this would be really useful to help figure out what your actual corn rootworm pressure is this year for seed selection next year, that type of thing. I'm going to drop a link in the chat for everyone so that you can talk to my master's student who's pushing this project forward. So in addition to those kind of general practices, the Bick Lab put together a range of corn rootworm trials. And we had some top performers. The top performers really were the bare traits that had pro associated with it. I think it was VPT4 Pro and Smart Stack Pro, which had the RNA advancement. Now, the issue with these two is they also had a whole range of other traits, and those other traits didn't seem to work. So by planting these traits with RNAi, we are keeping the resistance pressure high on these insects. We also worked with FMC, and it looks like capture LFR at the 8.5 fluid ounce rate per acre worked extremely well, and there was really no need for higher rates. So these are both ways to kind of keep the pressure, the selection pressure on these insects pretty low, as low as possible. And I would recommend picking one strategy, a trait or an insecticide, and not picking two. And we're still waiting on harvest data before we can kind of really talk about these results. There's also a BT corn trait table, which I would highly recommend. It's at this website over here. I just took a screenshot of the part 1 of that page, but this has been updated as recently as March 2023. So please take a look at these traits. And now I'm going to hand this over to Josh.
All right, Emily, thank you very much. And we are going to talk just a little bit more about making that seed selection choice for 2024, but we're going to think a little bit more beyond the insect side, and we're going to think about the weed management and the disease management that is necessary as well when we're selecting these seeds. So to begin with, this is a reminder for many, but a good way to begin that seed selection is to look at the variety trials. So this is the most recent small grains variety trial information. Perhaps there are still some wheat acres to be planted across the state. Just have some of the highlights here mentioned as a reminder in Sean's trial. If that yield has an asterisk next to it, it means that it's not significantly different than that highest yielding variety at that 0.1 reliability level. All right, so we can kind of look across there and see the different sites that these hybrids, that these varieties were checked at, and make that selection based off of that performance trial. Also, Damon Smith's lab participated this year again with a fungicide and disease screening on the wheat. So if they looked at fungicide and no fungicide on a few of these different varieties, and if there is I don't know the name of that sign, if there's that upward pointing symbol, that means that there was a significant difference in yield with that fungicide treatment. So perhaps that's a variety that is a little bit more prone to disease, and maybe that's why that showed a response. Let's take a peek at the next slide. Could you forward that, please, Emily? Thank you. Oops. There should be a soybean one. Yep, perfect. All right, and then just a little bit about the soybean variety trial. This is last year's information that will be coming out here shortly as we're thinking about making those choices. So the zones that were tested in: southern, central, north central, and northern, and that information is clearly stated in Sean's information when he sends that out. Also, that asterisk means that that those yields were not statistically different, than the highest one. So we might see a difference between 86 and 90, but we can have some assurance that that those are going to be very similar in how they might perform in our field. Then, as with the wheat, white mold was actually looked at the Platteville site. So if you can kind of see the Platteville site on your screen and go down through, those different varieties were listed for their white mold expression as well. And just a little bit of a note on that, Within Sean's book, it does say that anything like at 10% or under really has no impact. Even up to about 25% is really low impact on yield. So that kind of gives you something to think about as you're looking at those. There's a 48, a 28, and a 35. Those might be varieties that would be a little more susceptible to a white mold outbreak. One other thing that is highlighted is the herbicide trait. You'll see that on the far left-hand side. So either the enlist or the extend herbicide trait. So as we're making that selection, we're also thinking about that weed pressure that we might have in our fields next year. Let's take a quick peek at the corn selection chart. Thank you. So Dr. Lauer's hybrid chart is just a little bit different in how he shares that. He has a performance index for each hybrid. And you can see that down below, 50% yield, 35% based off of the moisture, so that hybrid's ability to dry down. And then 15% is ranked in there for the, supposed to be standability. I clearly have a misspelling there. But the zones are also broke apart for corn, southern, south central, north central, and northern. I believe we're looking at a short day, no, excuse me, a longer day hybrid in the southern region is what we're looking at from 2022 to 2021. Also, these have the traits listed. Like Emily had mentioned, these are most of the insecticide traits. Also, there is the Roundup Ready trait is listed there as well, and maybe a couple other herbicide traits. So when we're selecting that variety, these hybrid trials and variety trials are a really good place to look to give us some of that data to help us make that decision, so we can start out with maybe the best variety for our field, along with keeping in mind the herbicide technologies and the traits that are built into those varieties as well. Next. Okay, so just measuring that risk for our 2024 season on the insect side. You see I have crop rotation here highlighted 3 times, just to kind of bring out that point that within our crop rotation, we have a really strong pest management tool in that. So don't disvalue that. That is a really important part of managing that pest pressure for 2024. But on the insect side, what is the established population? What are some of the insects that we're thinking about that we know are going to come back and bother our crops next year? What's that migrating population? So we mentioned the true armyworms and some of the other moth pests. Many of those do not start the year in Wisconsin. They start somewhere else and then they migrate here, and then we get to work with them after that. Weed pressure, again with the crop rotation, field history and herbicide resistance. So when we're making those variety selections, think about where we're going in the fields and what we've been working on in those fields for weed management and in years past. And then finally, the disease pressure, weather outlook, and hybrid susceptibility are things to keep in mind when we are trying to select varieties that are most hardy against some of the disease pressures that could be coming to our fields. Next. Okay, just a little bit about weed pressure. These are a couple of maps that have been updated fairly recently. On the left side, that's water hemp. And there's a really good tool that the Weeds Lab has, or I shouldn't say tool, informational chart that if you have a chance, look through that. But all the counties in red are glyphosate resistant water hemp has been identified. So there's other herbicide resistance that's built in there as well. Certain fields might have certain levels of resistance, more or less. But those are kind of the counties where we're really thinking that we need to have an extra tool in the toolbox for water hemp management. And then Palmer amaranth is a weed that is very scarce, I will say, but all the counties that are highlighted in red, Palmer amaranth has been identified and is a weed very similar to water hemp. It's in the pigweed family. That does take special care and management to keep that from becoming a bigger issue. Next. Okay, and then, so do we have some documented cases of herbicide resistance? We talked about that a little bit on the last slides, but it was pretty vague. There is a table here that just shows, you know, we've been working on this for quite a while, trying to identify which weed species and which herbicide sites of action, you know, work best for us. And this chart's available to just kind of give us that background knowledge of what's developed resistance in the past. I included the chart on the bottom left. This is from the soybean variety trial guide, just as a comparison. Oftentimes that yield piece is much more variety based than it is based off of which herbicide technology we have built into it. There is a slight difference there. You can see the AB from the South region with the Enlist compared to the XtendiFlex, but the idea is, you know, select that variety for the yield potential, but make sure we have the herbicide trait that we think is going to help us in the future for that upcoming year. Next. All right, a little bit on disease pressure. That weather outlook piece is obviously a tricky one to think about at this point, but once we get a little bit closer and we get in season, there's a couple of really good tools available. If you have not used these yet, the Tar Spotter app and the Sporecaster app, they continue to be updated with new information, new weather data, new scouting data to make these even more impactful yet. So there was a few farmers that I know utilized these tools this year and really leaned on them hard to make this decision whether to apply a fungicide or not. And it'll be interesting as they get into the harvest time and get some yield analysis, but these tools seem to do a really good job of predicting which fields had the biggest risk of a tar spot or a white mold outbreak. And then we could really just lean on that tool. If the forecast was low, we really did not see that pressure creep into the fields. Next. Okay, this is some work from 2018 when tar spot really first hit the southern part of the state. And I like these charts. There's all the different hybrids that Dr. Lauer had in his hybrid trials. I believe this was in Montford, so in southwest Wisconsin, along with some other data that was built into. But the way we read this is we look at the bottom of these charts. It says tar spot severity. So as that tar spot severity increased, in general, the yield was impacted. Okay, so if we can find the information that our seed dealers have, you know, we can find hybrids that will hold up better than others, and do have that higher yield potential in the face of some type of a disease outbreak. So just wanted to kind of share those. Next. Okay, and then finally the seed treatment side. What's on your seed? This is a updated document that's available at the IPM website, Nutrient Pest Management site, if you're interested in learning a little bit more about these. Also, these seed treatments are definitely being talked about. A lot of these fit the neonicotinoid chemical class, so we need to be careful and aware that those are very powerful tools, and you know, maybe we need to make sure we're really needing these tools in the fields when we're putting them out. Maybe just treating every seed might not be the best option, but go ahead and read through this. It helps us understand a little bit more what some of these different seed treatments are that are available when we purchase our seed. Next. All right, and just the references and the links there. I mentioned those two Whisk Weeds documents. They're at that story maps link at the bottom, and then the crops and soils information. If you want to learn more about the grain production So those variety trials, they're at the Crops and Soils website, along with the pest management information that I shared. That's at the website as well. Just pick a different tab. And that's all I have. I believe there's one more slide, Emily, but that's all we have for today. And we are right at time. So I'm going to turn it back over to Sam. Thank you very much.
All right. Thank you, Josh. And thank you, Emily. We really appreciate you sharing your time and expertise with us today. Scott, if you could share the CCA QR code, then participants, if you are a CCA, feel free to use your CCA app to scan the code when it shows up here. And if that's not working for you, you can use the Qualtrics link that will be put in the chat box momentarily.